Let me ask you something. If you're planning to pursue engineering in your bachelor's, or you are an engineering student right now, or you are the parent of one, what's the plan? Get a degree, get placed, crack a product company, maybe go for a master's abroad. That's the plan most people have, and it worked. For a long time, it worked really well. But here's what's changing. A generic engineering degree, even from a good college, is starting to look a lot like a commodity. Companies aren't just hiring engineers anymore, they're hiring engineers with a very specific skill in a very specific field who can solve very specific problems. And the gap in salary between a generic engineer and a specialist, it's not 20% anymore. We are talking 2, 3, sometimes 5 times the salary. Hi, I'm Akhilesh from AdmitAbroad, and we have helped hundreds of students get into top ranked universities across the world. So today I want to talk about 5 engineering degrees, including some tech adjacent ones where the specialization is already paying off globally. We are going from 5 down to number 1. I'll give you the salaries, the demand numbers, the eligibility for bachelors and masters. So let's get right into it. Most engineering students don't seriously consider biomedical engineering, and I think that's a mistake. Here's what this field actually is. It's a degree that sits right at the intersection of medicine and technology. The people in this field are building things that didn't exist 10 years ago. AI-powered diagnostic tools that detect cancer, wearable devices that monitor your heart in real time, 3D printed tissues, implantable devices that deliver medication directly inside the body. These are not science fiction projects. They are built right now at universities and companies that are actively hiring. The numbers back this up. Specialized areas within biomedical engineering, that is tissue engineering, bioinformatics, are growing at 13 to 15% annually through 2030, which outpaces almost every other engineering subfield. The median salary for a biomedical engineer in the US already crosses rupees 1 crore per annum, with specialists in medical devices and AI diagnostic earning significantly above that. And the global bioprinting market alone, just one slice of this field, is projected to grow $3.75 billion in 2026 and $16.3 billion by 2034. Now, where should you study this? Top 5 countries for biomedical engineering jobs right now, purely based on job demand, are the United States, Germany, Canada, the UK, and Australia. The US leads on salary. Experienced professionals earn rupees 6 lakhs to 10 lakhs per month. Germany and Canada are not far behind, and both have strong post-study immigration pathways for engineers. For eligibility, if you're coming in the bachelor's level, you need a strong class 12 with physics, chemistry, and biology or mathematics. Most universities abroad require at least 75% in these subjects. And at the master's level, you need an undergraduate degree in biomedical engineering, mechanical engineering, electrical engineering, or life science. Some top programs also accept biotechnology graduates, and here's something worth noting. A 94% employment rate within 6 months of graduation for UK biomedical engineering graduates was recorded by the Higher Education Statistics Agency. That's not a number you see in many other fields. Every time we talk to an engineering student about robotics, we get the same reaction. Won't AI and robots take all the jobs? And we always say, yes, some jobs. But someone has to build these robots. Someone has to program them, deploy them, fix them when they break, and design the next generation. That person is robotics engineer. And here's the thing, there are not nearly enough of them. The global robotics industry is projected to surpass $205 billion by 2030. The US Bureau of Labor Statistics reports that the demand for robotics and mechanical engineers is growing at 9% through 2024. Faster than almost every other occupation on their list. Median salaries in the US is around rupees 1.2 crores per year, and a senior engineer working in aerospace automation, surgical robotics, or autonomous vehicles go considerably higher than that. The top 5 countries for robotic engineering jobs based on hiring demand are the United States, Germany, Japan, South Korea, and Canada. Japan and South Korea are the global leaders in the industrial robotics manufacturing. Germany leads in the automotive and precision engineering automation. The US leads on salary. Starting salaries around rupees 1 crore, with senior engineers in aerospace and autonomous vehicles going significantly higher. On eligibility, for a bachelor's in robotics or mechanics abroad, you need class 12 with physics and mathematics as a core subjects, minimum 70 to 75% aggregate depending on the university. At the master's level, the ideal undergraduate backgrounds are mechanical engineering, electrical engineering, computer science, or mechatronics. Some universities also accept electronics and instrumentation graduates. Most top programs in Germany and the US require a GRE score and relevant project or internship experience. And for a mechanical, electrical, or computer science student, robotics engineer abroad is one of the most highest ceiling paths available right now. I want to be honest about why this degree is on this list. It might not be the first thing that comes to mind when you think highest paying engineering career. Every country in the world has made a legal commitment to net zero by 2050. You can debate the politics of climate change all you want, but here's what you can't debate. The infrastructure build out that comes with a commitment is already underway, and it is one of the largest engineering projects in human history. Someone has to build their solar farms, design the offshore wind systems, engineering grid storage, and figure out how cities actually run on clean energy. That's a renewable energy engineer. The International Renewable Energy Agency reported that renewable energy jobs globally hit 16.2 million in 2023, up 18% in a single year. The projections point to over 30 million positions by 2030. The IEA separately warned that the number of the new qualified energy sector entrants globally needs to rise by 40% just to keep pace with demand. On salaries, entry-level renewable energy engineers are starting at rupees 65 lakhs to rupees 90 lakhs in US and Europe. Senior engineers in offshore wind and grid systems command rupees 1.3 crores to rupees 2 crores per year. The top 5 countries for renewable energy engineering jobs right now are Germany, the United States, the UK, Denmark, and Australia. Germany is running the most ambitious energy transition in history. Denmark leads the world in wind energy technology. The UK has some of the world's largest offshore wind installations. Australia is rapidly scaling solar and storage infrastructure and actively recruiting international engineers to fill the gap. For eligibility at bachelor's level, physics and mathematics in class 12 are non-negotiable, typically with 70% or above. Some universities also prefer chemistry. And at master's level, an undergraduate degree in mechanical, electrical, civil, or chemical engineering is the standard entry point. Environmental engineering and energy systems graduates are also accepted at most programs. Universities in Germany like TU Berlin and RWTH Aachen have some of the strongest programs, and many are offered in English with no tuition fees, making Germany attractive, especially for Indian students. I'll be very direct about this one. Cybersecurity is the most structurally guaranteed engineering career on this entire list, and I don't say that lightly. Think about every degree I've mentioned so far. Biomedical, healthcare industry needs. Robotics, manufacturing needs. Renewable energy, energy sector needs. And cybersecurity, every single industry needs you. Healthcare, banking, government, defense, retail, and logistics. It does not matter what sector you work in. Every organization on earth is a target, and every organization needs protection. This is no industry exception, and the shortage is severe. Right now, there are 3.5 million unfilled cybersecurity positions globally in 2026. The US Bureau of Labor Statistics projects 29% job growth in cybersecurity through 2034. The average across all professions is around 4%. The gap tells you everything. Salaries reflect that shortage. Entry-level cybersecurity in the US starts between rupees 80 lakhs per annum to rupees 1 crores per annum. Experienced professionals in cloud security, penetration testing, or security architecture regularly earn rupees 1.5 crores to rupees 2 crores per year. But here's the angle that makes particularly powerful for Indian students specifically. The US, the Germany, UK, Canada, and Australia have all created dedicated visa and immigration pathways for cybersecurity professionals. This field has been designated as critical national infrastructure in multiple countries. This means studying cybersecurity abroad is not just a career decision. For many students, it's also the clearest path to permanent residency in a developed country. On eligibility for a bachelor's in cybersecurity or computer science abroad, you need class 12 with physics and mathematics in the standard requirement, with most universities asking for a 70% or above. And at master's level, an undergraduate degree in computer science, information technology, electronics, or software engineering is the typical entry point. Some universities also accept electrical engineering graduates with strong programming foundation. Most top programs require relevant certifications or project work. CompTIA Security Plus or equivalent is a strong addition to any application. Everything I have talked about today leads here. The biomedical engineer using AI to detect cancer earlier, the robotics engineer training machine learning models to make autonomous decisions, the renewable energy engineer using AI to optimize grid performance, cybersecurity professional using AI to detect threats before they happen. Every single field on this list is being transformed by artificial intelligence. And the engineers who can actually build systems, not just use them, but build them, are the highest paid engineers on earth right now. The numbers are extraordinary. The machine learning engineering job market is projected to reach 103 billion US dollars by 2030. Average salaries for AI engineers in the US hit rupees 2 crores per year in 2025. That was rupees 50 lakhs increase in a single year. The World Economic Forum projects 40% growth in AI specialist roles by 2030. But here's a number that matters the most. Global demand for AI engineers already exceeds supply by a ratio of 3.2 to 1. The jobs exist, but the engineers don't. Now, I want to say something that most people in this space won't tell you. A generic AI degree is already starting to get crowded. Everyone is pivoting to AI. The students who command the top salaries in 2030 are not just AI engineers. They are AI engineers with deep domain expertise. The people who understand both machine learning and genomics, the engineer who can build AI systems specifically for financial risk modeling, the professional who combines cybersecurity knowledge with AI threat detection. The combination AI plus domain depth is where the real premium lives. The top 5 countries for AI and machine learning engineering jobs right now are the United States, Canada, Germany, the United Kingdom, and Singapore. The US is still the highest paying by a significant margin. Canada has 3 of the most cited AI research labs in the world, like Mila in Montreal, the Vector Institute in Toronto, and AMI in Edmonton. And the express entry permanent residency takes 2 to 3 years for most ML engineers. Germany's industrial AI sector applied inside companies like SAP, Siemens, and BMW is growing fast, and the EU Blue Card now has a shortened path to permanent residence of 27 months. Singapore is the gateway to the entire Asia Pacific AI market, with the government-backed hiring at scale through AI Singapore and the National AI Strategy. On eligibility for a bachelor's in AI, computer science or data science abroad, class 12 with mathematics and physics is the core requirement. Strong performance in mathematics, typically 80% or above, is important here because the programs are quantitatively demanding at master's level, and undergraduate degree in computer science, mathematics, statistics, or electrical engineering is a standard path. Some top programs also accept students from information technology or electronics background, provided they have strong programming skills in Python and relevant project work. And I'll say this directly, the students who will command the top salaries in 2030 are not just AI engineers. They are AI engineers with deep domain expertise in healthcare, finance, or defense. The combination is genuinely rare, and companies pay extraordinarily premium for it. So let's bring this together. Every single one of these degrees has one thing in common. They are fields where the world generally does not have enough engineers. The demand is real, the salary is reflected, and the gap is not closing anytime soon. The question is not just which degree, it's which degree at which university, in which country, for your specific background, your specific goals, and your specific budget. That's exactly the conversation we have with students every single day. If you want to sit down and map out what the right path looks for you, the link to book a free consultation is right below this video. I'll see you in the next one.